If you ever built the JavaScript animation, you should have probably used the requestAnimationFrame like we used in the previous video. But here's the problem. If someone's browser runs at 60 fps and someone else's monitor runs at 144 fps, and your animation moves at completely different speeds for them, and that is a real issue. And the issue is something called delta time. What delta time is: how games, animation engines, and professional softwares keep movement consistent no matter what. And in this video, we are going to build it from scratch. A bouncing cube that moves at exact same speed on every device, every frame rate, and in every browser. So let's get into today's video. First, and let's see the browser. I have already created the HTML and its styling, and I have created the cube like in previous problem, and I am not going to show how to do the stylings here, because I have shown the basics in the previous session and in the previous HTML CSS series too. So you can figure out how to make a cube. So it's not a big issue. So our main goal here is to move this cube like in the previous problem. We have to move the cube from right to left and left to right. We need to bounce it back again and again in a loop. That's all. So let's go to the JavaScript, and I am creating a variable using identifiers. Creating a variable called the cube, selecting it by document, query selector cube, and then I am creating another variable called scene, selecting it by document. Again I am using query selector, and the class is scene. Now we have to define the position here initially. Like in the previous problem, we are doing the same procedure. The goal is same here. Just we are rectifying a small error or small adjustment or responsiveness according to the monitor. That's what we are going to do. We have done the responsiveness according to the screen size here. In all the problems, most of the websites we do this to make our website fit on all the screens. So it is also what we are doing in a JavaScript. It is also an important thing, because the website's appearance or movements, animations change according to the frame rates of the refresh rates of the monitors. So we have to keep that factor also in mind when creating animations for the websites or any other thing. So initially I am selecting the position as x is equal to 0. You should know what this is. This is the current horizontal coordinate of this cube. If you say this is the 0 point, that's all. That is what we are defining here. And next we have to introduce speed here, because the speed changes according to the frame rate. So that is why. There in the previous problem we wrote this differently. In basic frame rate animation, the speed means pixels per frame, but here we define the speed relative to the physical world. That means if 250 means if 1 real second pass on the clock, the cube must travel exactly 250 pixels. That is what speed here actually means. So as I have said, I am giving speed is equal to initially 250, and then I am introducing another thing called time tracking. So what first let me define it. I am giving last time variable and giving it value as 0. So what this means is, this acts as a memory maker that stores the exact timestamp of the previous animation frame. That means when the page renders for the first time, no frames have been rendered yet. that means when the page loads on the first time, no frames have been rendered, so our history starts at 0. That is why I am giving 0 value, and this is the most important crucial component for the delta time. To figure out how much time has ticked away between the current frame and the last frame, the engine needs a historical reference to subtract that or to get the actual value, current value. So now we can go to the brain of this logic, that is using the creating an animation loop. So to create the animation loop, I am creating a function called animate with the variable current time. Now we will write the program logics initially, and before that I have to introduce say another thing. When you use requestAnimationFrame and include this frame animate, you will also inherit the current time function. That means the browser automatically hands your function with a high precise timestamp. That is what happening here. That's all. This current time will be extracted from the browser in one way or the other. So we have to calculate the delta time now. To get the delta time, I am creating a variable called delta time, and I am writing a formula here. What formula means? Current time minus last time and divided by 1000. Let me explain it here. Here the current time minus last time, what this exhibit means, it subtracts our saved history from the exact present moment. That means the result is raw number of milliseconds. If we subtract these numbers, we will get the milliseconds value that elapsed from the browser, and that was very busy driving the planes. So the output will be in milliseconds. We have to get in seconds. So that is what we humans use. In JavaScript it will be calculated in milliseconds. In human values we use in seconds. So I am dividing it by 1000. If you don't know, I am reminding it again. 1 second is equal to 1000 milliseconds. So we are changing that, and now we have to set this delta time as the last time. So fix this delta time as last time, current time. So this current time is the last time now. So and then we have, now that delta time has changed, that means only according to this time the cube will move to some distance. So we have figured out the time, calculated the time. Now we have to calculate how much distance this cube is going to pass. So we have to update the position here. To update the position, I am writing a formula here again. X plus equal to speed multiplied by delta time. Why I am doing this is, this is a simple formula. We used it for the speed multiplied by time. The simple formula we use in mathematics and physics. Here I am adding this x here because I am adding this distance to global coordinate x, because we can see in the browser only when I add this global coordinate. For example, it is initially 0, the cube is at the 0th position. For example, take it as 10. If it moves 10 points, that means 10 pixels, the distance is 10 here, so the x is 10 here, so that x will get added here with the speed multiplied with the delta time value. So that is so the total x value will get changed to another different value. For example, let's say some 20 pixels, it will move another 20 pixels. That means from 0 it will be at 30th pixel. sorry, yes, it will be at 38 pixels. Total distance moved is 30 pixels. So now the position is updated. Now position point is now defined. Now we have to move the cube to that exact position. So to move the cube, select the cube and change the style. We have to change it to transform it. And what we are going to transform is using the translate in x direction, because it is a horizontal movement. So okay, and give it the x value. So that is the displacement value. So that's all. And we have to include the pixels here, because that's how that will command the cube to move to certain pixels. Now another important thing is the scene width. In the round ball, when we did the previous task, we have used the round cube here. So in the round cube, we determine how much this will move and at what point the round ball will bounce. The same here, but with a different method, because we are considering the frame rate of the monitors. So we are going to write another formula here. What we are going to do for that is, I am creating a variable called max x. That means the maximum distance in the x axis. I am selecting the scene and the client with property minus cube dot client width. We are calculating it by, go to the browser. I said scene dot client width. That means this total container, that is the scene here. So scene's width minus the cube's width. So the total distance will be excluding this whole point till the cube here. So this will get discarded, and this empty space will be the total cube, considered as a total cube's length. So that's what's happening here. That is the maximum x value here. And now another important thing I have said, what I said is bouncing. We have to bounce the cube back and forth. So to bounce it, I am writing if logic here. That means if x displacement is greater than or equal to the max x value, we have to declare x value as max x value. That's all. And we have to change the speed here, multiplied with -1. So that means it will come in the different direction, reverse direction. That's all. And now we have to bounce it in the other direction too. So if x is less than or equal to 0, we have to change the x to initial point. So this block is for bouncing from the left right to left. This is for left to right. We have to change the speed in multiplied by again -1. That's all. So now everything is fixed. The bouncing is calculated, and to bounce the cube should have a position, and the position is declared. To get the position, we have to move the cube. To move the cube, we need delta time, and for the delta time we have to calculate that, and that's all. Now we have to animate it. So I am calling the animate function using request animation to the animate function. So that's all. So this makes sure that the loop repeats again and again. So to make it all happen, we have to start the loop initial. So I'm again using the request animation frame and calling the animate button, sorry, the animate function. So that's all. Now the whole function is written. Now let's go to the browser again and I reload. See, it is moving. It is moving according to my monitor's frame refresh rate. If you use monitors with a high refresh rate, it will move even smoothly and according to the monitor's specification. So that is how it happens. So yeah, and yeah, that is it for today, and I hope you like my session. And in yesterday's previous video got only 3 views, and it is really discouraging to see that. And please give a like, and whoever is watching, please share the video. It will be really helpful. And yeah, and I will meet you guys in the next session with another nice animation. Yeah, bye, have a nice day.